All right, so this is our first section, is 9.3, estimating population standard deviation when it comes to it, okay? So I know last time we talked about estimating population mean and also proportion, so easing our way through the last section of chapter 9 is, now for standard deviation itself, okay? So let me review when it came to it, right? When we did population proportion, we used z-scores. When we did population mean, we used the t-values, right, the new distribution, which means for standard deviation, we're also going to learn a new type of distribution. This is going to be the last one we're going to be learning itself, okay? So the key thing is, when it comes to constructing this confidence interval, unlike the last two, where it's symmetrical, you plus and minus your margin of error to either your p or your mean, this is going to be completely different when it comes to it, okay? So that's one major thing with the difference, okay? Also, like I said earlier, we cannot use a normal distribution or the student t-distribution, but to use a new one when it comes to it. And that's called the chi-squared distribution or chi-squared distribution itself, okay? And it's a fancy x squared, hence it's, squared or chi-squared. So again, it's a big letter, okay? Now, when it comes to the new type of distribution, we've actually already seen it already. We just call it in a different name. So our chi-squared looks like this, which essentially is a skewed right graph. So the chi-squared distribution is literally a skewed right graph. That's it. So, kind of nice, right? We've already talked about it before, so it's not too much when it comes to it. So let's talk about a couple properties we have of the chi-square distribution. The first major property is, you guys notice, it's not symmetric. Right, the other two were symmetric, even though it is, normal or t-value symmetric. This is the only first one that's non-symmetric, okay? And just like a t-value, the chi-squared value gives you area to the right. So we're always going to be shading the right area itself, and we're always going to be finding the chi-squared value. So this will always be given to us. We'll always have to find the chi-squared value, again, just like a t-value. So the good news is it's very similar to a t-distribution in that format, okay, which is great part. Nothing completely brand new, okay. So on that concept, to find a chi-squared value is exact same way as finding a t-value. So we need two things. The first thing we need is to find an alpha, which again is the same, if you guys remember, it's 1 minus the confidence interval percent given to us, right, when it comes to it. And the second thing we also need is degrees of freedom, which again is n minus 1 in this case. Okay. All right, so using this distribution, all we're going to do is try a couple examples so you can see how we would do each one individually. Okay, so first example says find the chi-squared value when n is 30 and alpha is 0.05. Now the good thing is, right, they already give us alpha, so we know that one. Next thing we just need is degrees of freedom. And degrees of freedom is n minus 1, so 30 minus 1 gives you 29. Now the chi-square distribution is almost identical to the t-distribution. So if you guys have your formula sheets out, hopefully, we're going to go to that. So here's the first page of the formula sheet. So if you go, I think it's the second to last page. So here's t, and here we go. Right after it's the chi-square distributions, these ones right here. So again, very similar to the t-distribution. Just be careful, right? This is now the chi-squared. And it's the same thing as applied, if you notice. It's degrees of freedom going down the column and alpha being across. And it's the exact same process here we did earlier, right? Degrees of freedom going down and alpha going across. So when it comes to this question here where alpha is 0.05, so here's 0.05, and degrees of freedom is 29, well, we go down to the 29th column, which is right there, and see where they intersect. So in this case, our chi-squared value is going to be 42.557. Okay. So we go back. So when it comes to it, alpha is our shading portion. So this is going to be 0.05. That's the alpha. That's the area to the right of it. And the chi-squared value we're looking for is 40. What was it again? 42? Oh, 45. No, look at it was 42. 42.557. Okay. Now, before I go any further, there's one thing I completely forgot is one last property as well, is a chi-squared value is non-negative. What that means is it only starts from 0 and it goes all the way to infinity. So you'll never have a negative chi-squared value. It's always going to be positive because it starts from 0 and just goes on for forever. Okay, so one little quick comes to it. I forgot about to write that down as well. Okay, so that's it. That's how we find a chi-squared value. Very similar to a t-value distribution itself. Okay, so we'll try a couple more examples. All right, so let's suppose alpha is 0.01 and n is 44. So again, this is our alpha. Okay, and degrees of freedom is going to be 43, right, when it comes to it. Okay, all right, so now we can go back to our portion. So alpha is 0.01, which is right here. Go down to 43 degrees of freedom. And, well, we have a problem. There's no 43, right? So we got to kind of do the same thing we did for degrees of freedom when it came to t-values. We're going to have to round because our graph isn't, perfect, so it doesn't give us everything we actually need. So if we round, well, 43 rounds to 40, so we're going to use 40 as our degree of freedom to make ourselves there. And we go across to the 0.01. So our chi-square value is going to be 63.691. And there we go. So that's the chi-squared value we're looking for degrees of freedom of 43 and alpha 0.01. Okay. So mine got a little cut off here. So why don't you guys try the next two when it comes to it. So this one corresponds here and the next one down there. So you guys can just quickly pause the video, try it out, and then we'll do it together. So 3, 2, 1, pause. Okay, so hopefully you guys tried them. So now let's do them together. So it's a little fuzzy. Come on. There we go, focus. All right, so the next one is when alpha is 0.005. So 0.005. Okay. And degrees of freedom is going to equal to 20 now, right? 21 minus 1 is 20. That's 20. Okay. All right, so now if we go back, degrees of 0.005, so it's the last column. Go down to 20 degrees of freedom, which is right here. And there is our chi-squared value. Okay, and there we go. Okay. And the last one right here. So given chi-squared value of, we want to find the chi-squared value when n is 5, and now it says the confidence interval of 90%. Okay, well, if you guys remember, this is the first time we actually have to find alpha. Remember, alpha is equal to 1 minus the confidence interval percent given to us. So 1 minus 0.9 gives us 0.10. So that is our alpha now, with degrees of freedom of 5 minus 1 is 4. So we shade our alpha, and now we find the chi-squared value associated with that. Okay. All right, so let's see what we get. All right, so go back to our portion. So alpha being 0.10 and degrees of freedom of 4 gives us 7.779.